A logical expression is any expression that can be true or false. So for example, 3 less than pi is a logical expression because it is true, and element 5 comma integers returns true, so that is also a logical expression. More complicated logical expressions can be built up using operations like and or, and not. For example, this returns true because 3 is odd and 3 is less than 4. This returns true because at least one of the arguments is true, which is how logical OR works, and not of that expression returns false. There are common special notations for all of these things. In standard input and output, ampersand ampersand represents and, two vertical bar characters represent or, and an exclamation mark represents not. Those are the notations for input using a standard keyboard, but there are also traditional mathematical notations where this wedge character means logical and, this character that looks a bit like a V means logical or, and there is also a special character for logical not. In programming, logical expressions come up when a program needs to do one of two things depending on whether something is true or false. This if statement, for example, returns expression 1 if x is odd and smaller than 4, and expression 2 if it isn't. Similarly, here is a one-line program with a logical expression in a pure function that picks out elements in a list that are odd and that are smaller than 4. Logical expressions are also used in purely symbolic calculations for representing conditional results and for representing assumptions about parameters. For example, the second argument in the simplify function is used for assumptions about parameters, like in this input where the second argument specifies that the variable n is an integer, or in mathematical language, the second argument specifies that n is an element of the domain of integers. There are special notations for these things too. There is an operator that looks a bit like the Greek letter epsilon that means is an element of, and the domain of integers is represented by a special character that looks like a double struck Z, so that input to simplify could also look like this. These notations can also come up in output. Here is a result from solve where these notations are used in specifying that n can be any integer. Logical expressions are also called Boolean expressions, so the word Boolean sometimes comes up in the names of functions for working with logical expressions. For example, this uses the Boolean variables function to pick out the variables in a logical expression. The Boolean table function shows the values of a Boolean expression for all possible combinations of the values of the Boolean variables in that expression. For example, this shows the value of the logical expression P or Q for all combinations of P and Q. This shows that same result from the Boolean table function formatted as a conventional truth table. Any logical expression can be given in many equivalent forms, and often the goal when working with logical expressions is to transform one expression into an equivalent form that is somehow simpler or more suitable for some application. For example, this uses the Boolean convert function to transform one logical expression into a different equivalent logical expression. These expressions are equivalent because they give the same result for all possible values of the Boolean variables. The particular form of the logical expression which is returned by the Boolean convert function by default is called disjunctive normal form, which is sometimes abbreviated with the initials DNF. The disjunctive normal form of a logical expression is a form where the logical expression is a logical OR of logical ANDs. That terminology comes up because logical AND is also called a conjunction and logical OR is also called a disjunction. So disjunctive normal form means a disjunction of conjunctions. Disjunctive normal form comes up in other situations as well. For example, the reduce function, at least for simple equations, gives a result in disjunctive normal form. That doesn't always happen though. For example, this result is not in disjunctive normal form, but it can be converted to disjunctive normal form using Boolean convert. The Boolean convert function can produce several other forms. The desired form is specified in the second argument. For example, this gives disjunctive normal form, which is the default, and this gives a form based on if statements, which can be useful in programming. And there are several other possibilities. This gives a form based on an operation called NAND, which is the logical not of logical AND. The logical NAND operation has a special notation, which is a wedge with a bar on top. You can use input form to see the NAND functions without that special notation. It turns out that any logical expression can be expressed in terms of the logical NAND operation. There is also a NOR function, which is logical not of logical OR, and XOR, sometimes called exclusive OR, which is true if one or the other of the arguments is true but not both. All of these functions can be expressed in terms of each other using Boolean convert. For example, this converts exclusive OR to a form based on logical not and OR. For one last example to illustrate the kinds of things that can be done with logical expressions, comparing logical OR, which is true if any one of the arguments is true, and logical AND, which is true only when all of the arguments are true, brings up the observation that there are, of course, intermediate possibilities, like, for example, a function that is true if some specified number of the arguments is true. That intermediate possibility can be expressed using a function called Boolean counting function. Here is a Boolean counting function expression which is true if 2 or 3 of the arguments are true and otherwise it is false. Like any other logical expression, a Boolean counting function can be expressed in terms of logical AND and logical OR and logical NOT. Boolean counting function returns such a form by default, which is actually a disjunctive normal form. This result has 7 terms in it, but that particular result actually has a small bit of redundancy in it and can be gotten into a disjunctive normal form with 6 elements using a function called Boolean minimize, which returns not just a disjunctive normal form, but a minimal disjunctive normal form. A good place to find links to more information about logical expressions and logical operations in the Wolfram language is the guide page on Boolean computation.